Okay, we're back. We're going to finish out section 1.1 in this video, and we are going to talk about the midpoint of a line segment, finding the distance between 2 points, and finally graphing circles, what the equation for a circle looks like. So let's jump right in. So we finished out the last video by talking about graphing a line by plotting points, and then we learned that if you found the intercepts, you could connect those, and that also gives you the graph of the line. So I want to point out a difference between two terminologies that I think in English sometimes we don't think of these as being two separate things. But a line, when we just use the word line, just like this line that we graphed in the last video, it extends forever in both directions. So if you just use the word line in mathematics, it means it keeps going. In English, we think of a line as having a length, but really in math, that line just continues out in both directions. So in order to talk about a piece of a line that has two stopping points, we use the words a line segment or just a segment. So when we're finding the midpoint of a segment, we're taking a piece of a line that has two endpoints and we're finding right the point that's in the middle. So we're going to start by just drawing a segment on this graph, and then we'll look at what its midpoint might be. So let's draw a segment that connects the dots, the points 3, -1. So learning what we used, using what we learned in the last video. 3, -1 is 3 to the right and down 1. That's our first point. And then 7, 3, that's 7 to the right and up 3 and making another point. So the line that connects those would continue going forever in both directions, but the segment starts at that first point and ends at the second one. And depending on how neatly you drew that, visually, you can probably tell or make a good guess as to where the center of that line segment would be. So if we just visually look here, it just so happens that this line just goes right through the corners of our boxes. That's not always going to be the true, but in this case, it connects easily. And then right here in the middle, and I'm going to highlight that in yellow, looks like visually would be right at the center. We're going through diagonally these boxes. There's 2 on this side, and then there's 2 more here. So it looks like this center, or the midpoint of this line, is going to be at the point, that would be 3, 4, 5 for the x and 1 for the y. And so that's just doing a visual look. That's what it looks like. So that's what goes into, I guess there's not really a blank for it, but it's answering this question right here. What appears to be the center. And then the definition, I've already told you this, that is known as the midpoint. So that's what goes in that blank. Okay, but this was a very unique line in that it had nice numbers. It was very easy to follow the line and find the midpoint because it went right through the corners of where the x's and y's connect. So it had nice even numbers. That's not always going to be the case. So we need a mathematical way to calculate this if we don't have a nice graph like this. Now, one thing I want you to do is I do want you to learn this formula. But myself personally, sometimes it just is easier for me to understand where the formula came from. And so I'm going to try to do that as we go through the semester, is explain where formulas come from, because if you're just memorizing numbers and memorizing the formula, it's really easy to get things turned around, especially with, they have the nerves of taking a test. But if you understand where it came from, you can develop that formula yourself and not have to rely on just the memory of the formula. So when you're thinking about finding the midpoint, I want you to think of averages. So for the x, for this 5 right here, that is the average of the x's of the endpoints, the points that we're connecting. So the x for the first point was 3, the x for the second point was 7. If you add those together and divide by 2, which is how you find an average, that gives you 10 divided by 2, which is the 5. So if you just remember that you need to average the x's to get your midpoint x value, you're going to get that right. And then we're going to do the same thing with the y's. -1 plus 3 is 2. And divide by 2, because there were 2 numbers that you're averaging, and you get 1. But we are going to write that out in the formula, and some people just prefer to memorize formulas, and that's fine, and you're not going to go wrong doing that. I just know for myself, sometimes it's hard to get it all straight on the formula, and I don't want to mess that up, so understanding where that formula comes from is very helpful. So let's look at this formula. If the endpoints are, and here's some notation that we're going to use, instead of just x and y, since we have 2 points, we're going to call it x sub 1, using a little subscript for the 1, and y sub 1, that's our first point. And that just represents, so in this case, the x sub 1 would be the 3, the y sub 1 would be -1, and then we do the same thing for our second point. So this is just taking that example and making it generic. So to average the x's, we're going to take x sub 1 plus x sub 2 and divide by 2. So that's what goes here as the formula for the x coordinate of the midpoint. Adding those two x's together and then divide by 2. And I'm not trying to type this because of the subscripts, and hopefully you can read my writing. And then do the same thing with the y's. So put a little asterisk next to this so that you remember this is where the formula is. When you go back and to do your homework, you're going to want to be able to find that formula. So let's just do one more example. That's not the same one we just did. No, it's not. Okay, so midpoint, this one's strictly from the formula rather than graphing it. So -3 plus -5 is -8. Divided by 2 is -4. And then for the y's, 2 plus -5 is -3 divided by 2. This one doesn't come out even. So this one would have been one that if we had graphed it, it wouldn't have been nice, easy numbers, and we would have been like, well, I can tell that it's in between -1 and -2, but I can't tell exactly what it is. So this is definitely one where we want to use the math formula. Now that -3/2, I'm fine in an algebra class, you leaving that as an improper fraction, which means the number on top is bigger than the number on the bottom. But probably, since we're talking about a point, we would probably want to write that as -1.5 or -1.5. Either one of those means the same thing. And that way, since we are talking about points on a graph, you're seeing that that's in between -1 and -2. Okay, let's talk about distance. And again, I like to explain to you where these formulas come from, but at the end of the day, if you want to memorize the formula, that's fine as well. So the distance between 2 points. So we have 2 points. We're going to call it point P and point R. And notice we've used that same notation that we used before. Our first point is x1, y1. Our second point is x2, y2. And then we want to know how far are they apart? What is the value of D if that is how far apart they are? Is that 5? Is that 8? Is that 17? What is the value of that? So I'm giving this to you as 2 theoretical numbers instead of actual numbers. But what you can do, if you want to know how far this is, you can draw the triangle in that one of the legs of the right triangle is just a horizontal line. So when we go across here and make point Q that forms the triangle, we're making that by starting at our first point and just going to the right, straight across horizontally, and then going straight down to our second point. And that makes a right triangle. And if you remember from geometry, you can find the sides of right triangles. If you know 2 of them, you can find the third one. So if we know how long this distance is, and I'm going to call it A, and we know how long this distance is, I'm going to call that B, we can use Pythagorean Theorem. In Pythagorean Theorem, we usually use C to represent this hypotenuse, this longer side. I'm going to use D since we're talking about distance, and I'm going to say D squared equals A squared plus B squared. You guys remember that from your geometry classes? So if we know A and we know B, we can plug those in, square them, and that tells us what D squared is. And then to find D, we just take the square root of that. So do we know the lengths A and lengths B? Well, if you look at point Q and point P and do a comparison here, notice their y's are the same because they're at the same height. They're the same distance above the x-axis, right? Because we just went straight across. So if we wanted to know that distance, we're really finding the distance between kind of on a linear basis, you know, one-dimensional, x1 and x2. So if we subtract x2 from x1, we know what this distance is. So that would give us distance A. So I'm just going to write that above A. It's equal to x2 minus x1. And then for distance over here, let me erase my blue circle, neaten this up a little bit. If we want to know this distance between points Q and R, notice the x's are the same because we're the same distance to away from the y-axis, so the x's are the same, so the distance we want here is subtracting the y's. And so B would be equal to y2 minus y1. And it doesn't matter if you take y2 minus y1. The standard way of writing the formula is the y2 minus y1. You're going to get the same number once you square it. So just remember that you're subtracting the x's and then squaring that. Oops. And so that's our a squared. Okay, x2 minus x1, squaring that, plus y2, and I'm using parentheses because we have to do the subtraction before we square. In order of operations, if I didn't use parentheses, it would say we would square first. Okay, so I'm going to send that out. And then that would tell us what d squared is, so we have to take the square root of whatever that answer is. So we're going to do the subtraction, square it, do the subtraction, square it, and then take the square root of the whole thing. Okay, the last thing in this section is to talk some about circles. And the reason this goes along with here is the definition of a circle. If you think about it, it's points that are all the same distance from the center. So that's our definition here that we're going to use for a circle. A circle is all the points in a plane. So this is a flat thing. It's not a sphere like a ball. It's a flat circle that are equal distance. So those two blanks are distance, equal distance from a point. And we know that point is called the center. Okay, so out here to the right, I am going to draw a circle. I'm going to start with the center. So this is the point in the center that we're talking about right here. And then we want all the points that are the same distance around it. Have you guys ever used a string to draw a circle where you hold the string in the center and you have the pin at the end of the circle or the end of the string? A lot of times carpenters do that. Also, you can use what's called a protractor, which does that same thing. There's a point you put down on your paper, and then you have the pencil that stays that equal distance. If you don't move it, you keep that same distance, and you come around here, and you could make a bunch of dots, or you could use that pencil to draw a continuous line. And all of those points, and my circle is not perfect, obviously, but all of those points are the same distance from the center point. If you drew out at any point, it's going to be the same distance. And that distance is called the radius. So let's fill in the blanks here. The radius of a circle is the distance from the center out to a point on the circle. And that's going to stay constant as you move around the circle and draw that radius in different places. So how would we find the formula for the radius? Well, we use the distance formula. If we go back up here to our distance formula, if our center is HK, that's kind of the standard for what we call the center of the circle. And then for our formula, we are going to pick a point on our circle, and we're going to call that point XY. So if the radius is the distance between these 2 points, we should be able to use that distance formula that we just learned. But instead of x1, y1, x2, y2, we're going to use hk and xy. So the formula for distance, and now we're going to use r because the distance that we're talking about is the radius, is the square root of x2 minus x1. Well, we're replacing that with our variables we're using here, so that would be x minus h squared plus y minus k. And the more standard way to write that is to square both sides, so we get rid of that square root. So we have r squared, get rid of the square root, and you have x minus h squared plus, oops, I left my x off there. Writing with a mouse is a little tricky. Y minus k squared. And we don't need the square root sign anymore. Let me neaten that x up just a little bit. Okay, so let's just graph a circle given the equation. So this is turned around a little bit. When we wrote our standard equation, we put the r first, so we have r squared equals. Here you'll notice that we have these two squared pieces first, and then we have just the number standing by itself on the other side. So we have to turn this around just a little bit in order to apply our formula. So the r squared is actually the 25. So if r squared is 25, what is r? What is our radius? Taking the square root of 25, we get the radius is 5. And then we want to know our center. Our center we call hk. In order to graph this, we need to know what our center is. X minus 3 represents the x minus h. So h is a positive 3. Y minus k in our formula is y plus 2. So since our formula is y minus k, what would we subtract in order to have y plus 2? We would have to subtract a negative 2. So that would be the same as y minus negative 2. So our k is negative 2, our y value of our center. So to graph this, because that's what we're being asked to do, we're going to graph the center first, 3, negative 2, 1, 2, 3, down 2, here's our center. And then we're going to just simply count out 5 in 4 directions, left, right, up, and down. And this one actually goes a little bit over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 5 this direction will be right there. And then we're going to carefully draw a circle that connects those 4 points. And you could find those 4 points algebraically instead of just counting on your graph. And that's by adding 5 or subtracting 5 to your x and y one at a time. So if we add 5 to the x, we'd have 8, negative 2. And we can see that point right here. If we subtract 5 from x, we would have 3 minus 5, which is negative 2, negative 2. You can see that point right here. And then we would do the same thing with y, 3, and then add 5 to the negative 2. And I'm adding the radius. I'm adding 5. So we have 3, negative 2. And again, we have that point right up here. And then we would subtract 5 from the y, which is negative 7. So 3, negative 7. So that gives us our 4 points that we need in order to graph the circle. And then we just connect the dots to have the circle. Okay, that wraps up section 1. The next video is going to start on section 2. So if you wanted to go ahead and do the section 1 homework, you could do that now, or you could just keep going with the videos and come back for the homework. Just don't put your homework off too long and get behind. In the next section, we are going to actually have a little short kind of inner section where we're going to introduce the graphing calculators and give you some tips for using that before we dive into the section 2 material.